Thank you. In fact, it's always humbling to come to a conference and you listen to the Constantine and all these children who are speaking about these things that they're so much smarter than you are, and it's too late for me. So I'm going to talk about microservice architectures, and to some degree this is a bit of a personal journey, but let me be clear, do not take this journey. It is too painful. So I want to sort of share some of my pain and kind of where my head is at now, pretty much hoping you will not try to do the same thing. I'm an independent consultant originally from the US. I've worked in a lot of countries. I've worked in India, I've worked in China. I've lived in London now for the last 6 years. So I kind of go where the fun stuff is. So this story kind of starts at the beginning. And in the beginning, we basically were building systems that I would sort of say resemble Stonehenge. If you notice, we have some nice towers and functionality. We have some cross-functional services. And please do not tweet, I was not the architect of Stonehenge. But I do have to say that when Paulo was talking earlier yesterday, he started talking about 1968. Well, I'm sorry, 1968 is when I started writing code. So I was having my life flash before my eyes as he was talking. And in fact, I was actually one of the people in IBM at the time in the early 70s where they experimented on with waterfall. So I was one of the victims of waterfall. So this is why you see a shell of a person today. So my story actually starts not back at Stonehenge, but really kind of in 2004. And this, I was working with an application, and I was in ThoughtWorks at the time. The application was about 1 million lines of J2E code. And at one point in time, it was the largest Sun-certified J2E application in the world. It was a leasing system, quite complex, sort of a bellwether application. And it has a very, very nice history associated with it. It started very, very well. It was originally a project that Agile was actually tried out in ThoughtWorks. Among other things, Martin Fowler and Ward Cunningham came and consulted on it. In fact, Martin Fowler actually joined ThoughtWorks after working on this. The book Enterprise Application Patterns, that book comes from a lot of the work he did on this application. So in some ways, it's a very influential application in our industry. So it started really well. So my part of this application gets in 2004, and what I found in 2004, and I'd gone to India to work on this because that's where most of the developers were working on at that time. What I found in 2004 was 1 million lines of code, about 2,000 tests, but 70% of the tests, acceptance test passing, was considered victory. They were happy. And I'm like, but that's 30% failing. And it was a different 30% every day. And they thought that was okay. There was a bug database with about 1,000 entries in it. It was like, what are these things? And it was like, oh, these are just the bugs. I'm like, okay. And they were still working on it. So they're still changing it, but not fixing the bugs or not getting the test to run. And writing new tests, well, it was like, why bother? The old ones don't run anyway, so why bother writing new ones? Now, again, this is an Agile shop, and it wasn't exactly what I expected to find. But this is what I got started with. And just to sort of give an indication, I do like my metrics to some degree. You'll find me as a process minimalist. I don't really like processes, but I will dust off metrics where they make sense. And one of my key metrics I like keeping track of what's going on in a project is count the new unit tests. Those who have never worked with me on a project won't realize, but I write a lot of code in a project. I get in there, I write code, because frankly, there's no secrets if you're writing code. You can try to manage a project and the programmers may not tell you the truth. But if you're a developer in there as well, there are no secrets. And so I count unit tests, because I know if we're writing unit tests, we are in fact getting more functions with more unit tests. It's easy to count them. And so here is the graph of unit tests across 5 months. Now, anybody tells you about systems that go up and down like this means you have a highly unstable system. So this is a 5-month timeline, and it vacillates from, sometimes even less than 40 all the way to almost 200. It just seems to vary all over the place week to week. Now, the really scary thing is those numbers at the side. So, take an average week of 80 things. How many programmers did I have on this project? Well, it turns out I had 40 developers. This is how many tests they're writing in a week. 40 developers will write 80 tests in a week, which means on average they're writing 2 a week, which means we're not really writing them. And in a bad week, obviously not doing much. In fact, I could probably find the 3 programmers, and if they were doing something else that week, that's why we're down. So clearly things were not working well. So being curious as a developer about why can't you write tests for this stuff, I decided I'd run an experiment. And so basically I wrote myself a test that says I'm going to write this test. And the concept of a loan is a fundamental aspect. This is a system that does leasing systems. And the idea of the loan was it's a very nice encapsulated object. It was part of the original design. It's a really great idea. But for some reason they decided that this little number 50, which should be encapsulated, you shouldn't be able to get to that number directly. People decided, yeah, I should get to that number. And so you wound up finding about 40 different places and 37 different classes that reached through and grabbed that number, which made it really hard to understand what's going on. So in my little test here, I basically said, okay, it's a very easy unit test. I'm going to go in on a Saturday so I don't get any disturbed. So I'm all there by myself. I can do this. And 5 hours later, it's not null. So clearly we're broken. And this was kind of the thing that, oh yes, it was a really nice system. Now, what happened? What happened to this thing that Martin Fowler and Ward Cunningham and all these really brilliant people put together this really gorgeous system and great conceptualizations? What happened to it? And so one of the things we realized very quickly, and I sort of brought some colleagues in, is 1 million lines of code. This application is not 1 million lines of code. In fact, one of my colleagues said, and very cleverly, it's really 100,000 lines of code trying to get out. That you can probably, if you really wrote this thing from scratch, it's not that big. It really wasn't that complicated. This is my colleague, Jeff Bay. Well, you'll come back to hear a lot about Jeff Bay because he keeps making really wonderful observations. But that was his idea about it. And lo and behold, I think he was right. Now, again, what happened? What went on here? And to some degree, the question is, well, were they just lazy programmers? Were these guys in India just being lazy about that? But I was in India. I was watching these guys. They were working hard. They're very bright guys. It wasn't a matter of being lazy. Well, maybe they were being sloppy about it. And, perhaps a little bit of that, but it didn't really seem to be true either. Maybe they were inexperienced. And it turned out, yes, they actually were quite inexperienced. These were university hires. They'd really not been exposed to Agile practices. They hadn't been exposed to what good programming looks like. And some executive in ThoughtWorks had decided it was a really good idea to send this application over to India where we have programmers and let's just let them work on it. And they destroyed it. But not intentionally. So there's a little bit also going to work is that the Indians didn't feel they had ability to say no. If they were being told by their US counterparts that you have to do this, they would just do it. When in fact, no would have been a good answer sometimes. Now there's a name for all of these things that we use a lot in our industry. We call it technical debt. But I will say that I personally believe that is another way of saying one of these other things. So when I hear people talk about technical debt, I'm really saying, what was it about your system, what was it about your organization that allowed you to create this problem in the first place? Putting a fancy name on it doesn't change the underlying issue. It should not have happened in the first place. So we'll come back and talk about that because some degree I've got a system now that makes that go away to a large degree. All right, so now we start evolving into this. So now I'm actually been assigned to China because that's where I was needed at the time. And I've actually gone into a Chinese bank and we're consulting with a Chinese bank to bring a service-oriented architecture to them. Now I got to say at that point in time I didn't know what that meant. I was fortunate I was working with a colleague, Jim Weber. He publishes books about this stuff. In fact, I think he's the chief scientist now for Neo4j. So I really had a chance to work with a very bright guy. And the challenge the Chinese banks were facing was they have all these banking sort of things they want to do just like everybody else wants to do in banking. Mortgages and loans, and they have bank accounts. They want to do all these things. And unlike some of the Western banks, particularly the US banks, which you can do all these things from when you're working with a teller, they also want to do these things with every other interaction technique they have with the customer. They wanted to be able to go to an ATM and get a loan. Now, in the West, I can tell you in the United States, that was not possible. But in China, they said it was absolutely feasible. In fact, even their smartphones back then were able to do some of these transactions that we in the West were just, at that point, dreaming about. So they really wanted to get to these systems in every possible way. And we were brought in basically to propose an alternative architecture to try to get basically one of our clients a foothold in these Chinese banks to help them develop software. So we basically decided what we really need to build is some sort of pub sub bus that in fact we wanted to sort of take advantage of the fact that if a customer is in front of me, I want that channel that has the customer to scream back into the cloud, I have a customer. And I want all these other things that are interested in customers to sort of wake up and say, oh, if you have a customer, well, we should probably get him a loan. Or, oh, I'm sorry, he owes us something on the credit card. Or maybe we want to refinance his mortgage. We want these little services to wake up and sort of say, oh, let's do that. Now, how you say that back to the customer, well, that's back to the channel. But the thing that you want to do as an interaction is sort of broadcast by these applications. And so it sounded like a really nice structure to put in place. And in fact, the client rejected it. They decided they really wanted to go buy a system from Citibank in North America because Citibank is Western and therefore it must be better. The fact that Citibank wrote this system in the 1970s and it wouldn't support your tellers or anything else, well, apparently was lost on them. So it was a nice idea, but one of the things I did walk away with was, in fact, going back to Jeff Bay and his 100,000 lines of code, I began to believe there was another way of thinking about this application. I was beginning to believe that, in fact, it's really 5,000 line of code little services trying to get out. That if I went back and restructured that application, I would probably restructure it differently than what we were talking about before. They didn't have to be a Stonehenge. So that's 2005. Now I've been sent back to the States. I'm working with a medical systems company. Of course, I got some new ideas here. Just the fact that the old one was rejected, but I've sort of got some new ideas. I'm always dangerous with new ideas. And we had a system where this company was in the medical systems business. They made X-ray machines and CAT scanners and MRIs and all these things. And so they had the idea that we should actually run hospitals, because if you run a hospital, then they'll buy your equipment. So they want to really run the whole hospital. And they were basically trying to rewrite their platform. They decided that the whole platform was written in C, so they're just going to rewrite in Java. And it's like, but that's not going to be different than the C implementation. And we're, again, trying to suggest some alternatives. So we suggested this PubSub again. It says, you have all these things that are trying to collect data, and you have all these other parties that are interested in it. The patient is interested in it, although a lot of cases you're not allowed to tell him things. But certainly you're a doctor, the staff running the emergency rooms or the critical care units, and of course accountants. They seem to love things about this as well. So we propose, again, sort of a PubSub base that says we want these instruments to publish little nuggets of information about what's going on, and we'll sort of route those nuggets to interested parties. So if you're getting an MRI, it's very interesting, and probably a doctor would like to read it, and perhaps, therefore, the critical care unit needs to know what's going on. And, of course, the accountant loves this because there's, cha-ching, cha-ching, we get more money. And we started looking at these little nuggets that you would publish. And one of the things we started thinking about is, first of all, we want to publish conclusions. I don't want to publish the raw data. Because, I don't want to send just X-ray images over to the patient, or certainly not even to the critical care unit. I need to send conclusions. What did I figure out as a service? Publish the conclusions. And so, again, if you have a CAT scan, and it was Jane getting the CAT scan, then the conclusion reached by the team doing the CAT scan may say, yes, there is concern. And that may ring little alarms on the doctor's system. It certainly may ring little alarms in other places. But publish the conclusion. If there's a reason to go back and get the original data, fine. Bind that later. But publish that. But it's also important to say this information is not always good. Knowing your blood pressure was perfectly fine 6 months ago does not help you today. However, probably your blood type, that probably hasn't changed in the last 6 months. So different data tends to have different longevity as you publish it in the cloud. And we thought it was very important to age this information out. So this is a little refinement we had in mind. Certainly if you're in critical care situations, heart rate and some of those things are things you want to be taking maybe every few minutes. So again, this was our idea about how to do these things. Again, the client said, no, thank you. We just want to rewrite our Java system. So when I was putting this presentation together, I actually began to figure out that I've been very unsuccessful in my career. But I still get paid well, which is kind of a good trick. All right, rolling right along. It turned out right next door to this medical systems firm was this financial firm that does funds and stuff in the U.S. Very successful firm. In fact, so successful, they don't make a good client. Good clients are clients that are desperate. They'll let you try things. But a client that is being successful is very, very hard to get change in there because there's all sorts of things that try to stop you, like, why should we do this? And you can't really answer it on faith. This is one of those particular clients. I decided I didn't want to work with them because of that reason. But my friend Jeff Bay, he got sucked into it anyway. And what he did was he said, well, we're not going to rewrite your system, but we'll prototype a new sort of style of architecture. He, in fact, was trying to get them to run faster. They were on, once every 3 or 4 months, we do a release sort of thinking. And he was trying to get them into a different place. So he was prototyping a new system architecture. It's not the real thing, but a prototype. And I create these things that I call the Bayesian service principles, named after Jeff Bay. And it was 2 profound observations Jeff made. First of all, he says it's okay to run more than one version of the service at the same time. And when I heard this, I was like, Jeff, this is wrong. We got a new service. We've got to make sure everybody's using it. He says, no, you don't. And I tried to explain to him why, and I couldn't come up with any reason, which generally means, it's a bad idea. I'm stuck in the Stonehenge age. I'm back at Stonehenge again. So he said that, and it was like, okay, that's kind of interesting. And then he said something else really strange. He says he only allows the system to deploy one service at a time. That's deployment. You cannot deploy 2 services, only one. And you then deploy another one. So, of course, he was trying to say you can deploy a service, and then you probably deploy the client that works with that service. You need to make sure it's that order. And obviously, it makes it more difficult, by the way, to replace it with a version 2 and kill all the version 1s, because that's lots of coordination. The result of these 2 really simple ideas is that we sort of have broken the dependency upon that old system. We've broken the coupling to that old code. Yes, we may have somewhat duplicate services running around doing almost the same thing, but Jeff would say, so what? And again, I didn't really have a good answer for that. Now, these guys were basically deploying about once every 3 months. With Jeff's little rules, they were deploying about 3 times a day. So he had a profound impact about how you do that stuff just by basically going through and breaking some assumptions about how we had to do things. So very quite profound. So I would consider that actually somewhat of a success, but it was a prototype. It wasn't a real system. But it, of course, gave me even more dangerous ideas. So I took Jeff Bay again, and he and I headed up to a large manufacturing firm, automobile manufacturing in particular. And we're trying to put a system together for those guys because they had to replace some parts in existing cars. Basically, some parts were getting somewhat antiquated. They needed to upgrade the parts. I can't really say much more about it, but it makes sense when you hear the domain. And it turned out there's just a lot of variations on information you're getting. So sometimes a call center would say, oh, I found a car that needs to be replaced. Sometimes a customer would call up and say, I have a car that needs to be replaced. Maybe it happens to be the garage he goes to get repaired. They notice it has that part needs to be replaced. So it turned out we were getting information from all sorts of sources in lots and lots of different formats and different information. So that was sort of the challenge. Now this company had an in-house vendor. Basically, I don't remember what it was, but yeah, the in-house vendor had it. And they estimated the change to their existing systems in order to accommodate this order replacement was going to be about 18 months, 15 to 18 months. They could modify the legacy system to do that. The business thought that was actually infeasible. We needed to have this thing done with much, much, much shorter time. So good, desperate client, allows you to go play. So again, unacceptable to the business. So what do we do in that environment? Well, I came up with this, what I call the pinball model. And I'll be a little clearer when I talk about it a little bit. But basically, the idea was I have these information packets. And basically, I need a lot of information in order to do the replacement order, to get the replacement order successful. But I'm starting out with different little tidbits according to where it came from. So maybe I know the name of the person and when he bought the car. Maybe I know the address of the residence that has the car. Maybe if I'm really lucky, I actually have the car vehicle number. But I have all this other stuff. And we decided what we really want to do is we wanted to sort of take this little pinball and bounce it around the various services and get more information until it's all filled out. So that was the theory. We just want to kind of bounce this packet around trying to get more information until it was full, in which case now we have a successful order. So how did we kind of do that? We started defining little services. And we tried to define a service as small as possible. So the responsibility was basically just fill in a little bit more information, but just one tidbit each. So I want service as small as possible, but it still does something interesting. So for example, maybe I have a service that's able to inject this, AAA information of some sort. But it needs to have a VIN, and it needs to have some other information in order to calculate that. And then maybe another service that can figure out the VIN, but it has to have a name. And maybe another service that needs to get a name, but it has to have an address. So what I did was we started taking these packets and started pinging them in these services. So, VIN tends to be one of the key things I want, so I sent this little packet off to the VIN service saying, here, can you figure this stuff out? And he says, well, no, I can't figure out your VIN because I don't have a VIN. But if you want the VIN, you can go to this other service and he'll help you get the VIN. So we go down to the other little service and you say, I can help you, but give me your name. Well, I'm sorry, I don't have a name. But there's this other service over here that can figure out your name. You have your address. And so we send it over there and say, we have an address. So let's fill in the name. And then we sort of bounce it through again. And we kind of go through again until it gets more information and more information and more information. And he finally gets filled out completely. So that was the idea. Now, interesting enough, as we're looking at it, of course, this is a legacy system. It has lots and lots and lots of databases. I mean, oh my goodness, the databases. But one of the things we decided was we wanted to carve up the databases in terms of their responsibility. Any given service can work with some tables, but they're the only service allowed to touch those tables. The only service. And it turned out the most interesting services were services that tagged around join tables, because join tables seem to be where the action is. When you sort of marry two static pieces of information together and making conclusions. Again, think back to the medical industry. We're trying to figure out conclusions and publish those. So we took the database and we sort of carved it up and we found, okay, what tables does this need? Okay, you're the guy that owns these tables, and we segregated all the tables very nicely. And basically, we were able to take that system live in 9 weeks. So a client was expecting, 15, 18 months. We went live in 9 weeks. Needless to say, client was very happy about this. Reputation was enhanced. And again, desperate clients, let you play some things. So I was very happy with that. In fact, I would consider that my success. Some of the observations we got from that, again, adding on to my new dangerous knowledge, I began to think about, when I used to talk to even Jim Weber back in China about this, where's a service boundary? What does a boundary of a service look like? And I started drawing back on my own background. I've been doing object modeling for, it's now almost 25 years now. So it's kind of my natural way of thinking. And I began to think that these services were just like classes in the traditional sense, that they have some behavior and they have some encapsulated data. But the encapsulated data is really the tables that they're allowed to own. And they don't want to share the data with anybody else. Good encapsulation again. But they still need to do something, not just spit the data back out to anybody who asks. They need to reach conclusions, very much like good services. So, and it turned out these things got really small. When you carve it up this small, it actually got quite tiny. I also have a small talk background. And it was people have talked about small talk and its influence and stuff like that. That was my first object language, so I was kind of spoiled. But one of the things I would learn and was taught, actually taught was kind of a kind word, beat the crap out of me was kind of another way of saying it. My teachers basically beat the crap out of me about, these are not subroutines, these are methods. In fact, if I called it a subroutine, I had to pay them 25 cents. And if I use the word, I'm calling this, can't call, that's a subroutine thing, 25 cents please. You're invoking a method, you're sending a message. It turns out that way of thinking really translates very nicely into service thinking. So after being beat up for many years in object modeling, I began to think this way as well. And again, the encapsulation turns out to be key. In fact, making sure nobody cheats and looks at somebody else's tables was kind of key to making this work. Now, we weren't without our little problems, so this is actually a new way of thinking about things, but we did have some issues come up that were, I guess not too surprising thinking back on it, but again, we're always surprised when we don't think about them ahead of time. One is we couldn't figure out what was going on. You got pinballs, right? Pinballs be dancing all around. And sometimes the ball would just keep going around and round and round, and we were waiting for it to drop out and would never drop out. Or sometimes we go back in there and the ball's gone. It's like, where'd the ball go? And so we sort of had to start doing some tracking and logging and how do you count cycles. So we started trying to refine some of these things, some of the things that tools do a much better job of now. But that was a little bit of our loss. That wasn't the biggest issue. The biggest issue turned out to be the programmers themselves. And it was an extremely bright team. I think the guy who started Cruise Control originally, he was on the team. I had Jeff Bay on the team, and of course he's a brilliant guy as well. So I had a lot of brilliant guys on that team, but they never had tried to carve a problem up this way. That they never tried to turn up in little services that encapsulate around the concepts and dance the information around. They really hadn't thought about a problem that way. So I had to roll off release 1. They sent me off to London. Release 2 came along, and the services started getting bigger. There's a little more sharing of the tables. So some of this stuff kind of began to fall apart. Not that it didn't work. In fact, we kept delivering very fast, certainly compared to the old cycles. We were still getting rave reviews within the client. The client still loved us. But to some degree, that pure implementation I had in mind originally, my pinball model, was beginning to sort of crumble a bit. There was a technical day at ThoughtWorks, and this project presented a poster at that and got an award. They got second place for an award for a technical poster. But the subject of the poster was what a bad idea this was. So I'm a little insulted by that. So I'll go back and say we delivered, but maybe it wasn't necessarily a good idea because of some of the issues we came up with. All right, roll the clock a little further. I'm off in London now. Oh, by the way, going back to this. So now I have a new view of this. Again, I'm a little smarter, or I think I'm smarter. I now begin to believe in 2006 that there's no such thing as a 5,000 line of code service. It's way too big. That maybe 500 lines of code is a reasonable size for a service. And so I've now refined my thinking even further. All right, so now I'm in London. I'm working at Ford. Ford's, by the way, one of the sponsors here. Great company to work for. It's really hard to describe what they do because if you look at some of the products, they have energy comparison, phone comparison, browser plugins, little toolbar plugins. We sell parrot cages online. We have a warehouse in Suffolk doing that stuff. It's kind of really, we actually have a controlling interest in 2 perfume firms. It's really hard to describe, other than the fact that we are probably very technology oriented and we like to market on the internet. Other than that, there are almost no rules for what we'll do. So these are our experiences of that. Because, of course, I got all these ideas now, starting back in China, going back to the States, and now coming into Forward. And, first problem to get unveiled is we're doing internet advertising. In internet advertising, Google's spitting out reports that you wouldn't believe about how you're performing. And taking that report data and analyzing it is very key to becoming very profitable. Because if you actually go out there and advertise on the internet, you're probably going to lose money on about 8 of the 10 ads you got out there. I mean, the numbers are really horrible about how ineffective it is. But the trick is to turn off those bad 8 and keep the good 2. And how fast can I do that makes all the difference in profitability. So, of course, now I got great new ideas of how we should build a system to accommodate this business. So I said pub-sub model. In fact, I was going to use something called Lambda Spaces. Originally came out of MIT. There's a version of Lambda Spaces built into Ruby called Renda. I think it's still in Ruby. Yep. No, it's still in Ruby, called Renda Spaces. Not that I know anybody's ever used them. I was trying to use it, but we'll see how that story turned out. So I decided, well, what we want to do is have, again, let's build our database, but let's make sure we segregate the tables and not let these tables be shared, because we're building a brand new database. I don't have to have sharing of that. Let's have little services, little agents that are sitting there analyzing this data and pumping it out to people who are interested, like these marketing people. So I want to be able to pick up a service, pick up this data, analyze it, and pump something out to this agent saying, here's something you should care about. And it's very much like my medical systems thing all over again. And so we start to begin to automate these recommendations. So the more we understand about what they're doing, the more we can sort of take this and make a clever service that says, oh, here's some new keywords you should try, or here's ones you should turn off. Maybe we even turn them off for you as we continue to evolve this system. So again, I was very excited by this. We were using an offshore teams for the implementation. Again, I ran across the problem that the offshore team did not understand the architecture I was trying to implement, and being offshore made it even more difficult. And I had a challenge that the CTO of the organization was a former Oracle guy who says, oh, you just need a big database and all this problem goes away. So reject it. Now, interesting enough, we come back a year later, same company, and we started to basically implement an Agile card wall, because one of the things I did bring into the company was Agile thinking. Not just Agile thinking for software development, but Agile thinking for everything in the company. Whether it's marketing and what marketing programs we're going to have, and we'd have story cards for that, and we'd show them to customers, and we'd have retrospectives with the customer about what stories we're playing, and we counted points. We put Agile everywhere, so we built ourselves an electronic wall to sort of track it very lightweight. But one of the things we started adding into the card wall was we started basically doing some back-end processing of these Google reports and started publishing alerts to the card wall to tell people who use the card wall that something interesting is going on. In other words, the system we rejected the year before, we started implementing again. And in fact, we continue to use that system. We actually went to Hadoop clusters. We run 5,000 to 7,000 jobs a day. There's 500 or 600 different services running across that period, all publishing into this sort of architecture. And so, to some degree, we finally have delivered a system that was along the lines we talked about. Now, observations and recommendations and revelations sort of from that experience. First of all, one of the things that was interesting is these little services became almost disposable entities. We didn't really care about keeping it around for long periods. If it was useless, we threw it away and wrote it again. They became literally very disposable entities. There's no reason not to keep it if I don't have to. And it turned out we loosely couple these things. So we really want them not to have a relationship to each other. So maybe they share a database, maybe they pull out a common reports, maybe they pass a RESTful packet, a JSON packet to each other. But fundamentally, they don't really care much about each other's internals. Now, the only thing I didn't like about that is they still knew that this one ran, and then this one ran, and then this one ran. There was a sequence that was sort of implicit in their relationship. So that coupling did exist. We also basically got rid of unit tests. So how do you get rid of unit tests? Well, first of all, we're talking about 100 lines of code. If you need a unit test to try to understand 100 lines of code to help you design it, then you're probably in the wrong field. So we did that. But what we did do is we required these little services, if they could not run, if they couldn't find the little Google report, if they got some garbage from somebody else, they should raise their hand and say, excuse me, I can't run. And we would take notice of that. In fact, big monitors in our room would go red. We'd go chase down what the problem was. That became basically our concept of replacing unit tests. Because most of the time our services work fine. Only when they broke, and usually we broke for some very strange reasons, will we go chase down the problem. A unit test would not have helped us find that sort of problem. Now, a side effect of that was we also got rid of our acceptance test. You say, well, you got a complex system. You need acceptance tests. Well, I would say, think back to India. I mean, I had a complex system there, million lines of code. I couldn't write acceptance tests and get them to run. It's a complex system. So it's going to be complex. Give up on that. But what we do like to do is we like to monitor the business metrics. By business metrics, what I mean is how many clicks do we get? How much money do we make? How many parrot cages did we sell yesterday? We decided that turned out to be a great acceptance test. First of all, it's not running once when I deploy, it's running all the time. And so when those metrics start going down, we are suspicious. Something may be going wrong. We just go check into it. Maybe it's our software, something we deployed. Maybe it's just bad luck. Maybe we have another oil crisis. Who knows? But it's suspicious. There was a paper given at the GoTo conference in Aarhus last year. And a guy was proposing basically you should write your only real acceptance test is business metrics. That is a true black box test. I don't have to understand anything about the internals to measure the business. If you measure the business, it's a very robust sort of test. And we found that to be true as well. The side effect of that was we don't care what language you write these services in. Let me tell you, the programmers got excited by that. They started playing with all sorts of things. We now play with Clojure. We now play with Node.js. You write it in Ruby. Maybe you write something else. We don't care. It's 100 lines of code. Well, what if you pick up somebody else's code and it's in Clojure? It's like, it's 100 lines of code. Understand it and rewrite in Ruby. I don't care. And so the programmers got quite excited by some of this stuff, and it drove a lot of the motivation as well. So, where we stand today. One of the things we inherited, we bought a company a few years ago, Uswitch, which does energy switching in the UK. In the UK, you can switch energy providers the same way we switch cell phone providers in the rest of the world. So it turns out to be a fairly lucrative business. But the system we had, which supported lots of sort of switching capabilities, was a legacy, Microsoft stack. I mean, it was absolutely gorgeous Microsoft stack in its time. Web servers, app servers, SQL servers, I interface here, I interface there, everything was exactly as designed. But we wanted to think about that differently because it was getting to be 10 years old. We had almost no programmer was ever around when it was written. Nobody really understood how it worked anymore, getting difficult to change. But we had two new influences on how we wanted to do this. We didn't want to turn the same team loose. You turn the same team loose and say rewrite it, you get the same architecture. We didn't want that. So we went to the other team that was doing the little small services, and we got a couple of those guys and brought them over. And they had two influences. First of all, we began to believe that events are more important than entities. We think about entities when we talk about object modeling. There's a customer, there's a sale. These are things that you want to hang your hat on. But according to sort of the event world, they're not really there. So what's really there is, it turns out, and this comes from one of our guys reading the Endoplex, which is obviously about Google, that Google basically just records all sorts of little events. If you go to a web page searching something, they recorded it. If you have to page down to find the search, they record it because something's wrong with it. If you click on an ad, they care about it. What if you click on the third entry and not the first entry? What if you click on the respelling that they suggested? That's important to them. Now, they don't know why it's important, but they record everything because it might become important in the future. We want to take that approach. Other influence was we thought we actually, our old system couldn't record everything because it couldn't have enough room, database was too slow. We had to pick what we wanted to sort of save. We don't want to lose the old stuff. The old history is very important to us. Again, going back to Google. And here we're influenced a lot by Clojure. Because Clojure basically has the idea that data is immutable. I mean, once you create data, it's there. You can't change it. I mean, if I was standing here at the beginning of the presentation, that is a fact. The fact I'm standing over here now is also a fact, but it didn't invalidate that fact. That's a perfectly good fact as well. Let's keep both the facts. Again, we're influenced by that thinking. So we took the old structure, which was basically, as you would expect, towers of stuff, Stonehenge all over again. And of course, we have a different Stonehenge for each of our services. We had all sorts of data we collected in runtime, and of course, you need a reporting database. It was not nearly that clear. The reporting database went back and forth, and eventually it gets back to the reporting database. It almost never worked. It was every day there was something in that pipeline that broke, and we didn't have reporting. But that's what we were stuck with. So our new goals, basically, we want to keep the history, because we think history really is important. We want to be able to run real-time analytics, because it's a real-time business. This is a business, in fact, that is all about making sales and making transitions. We weren't able to figure out until end of month where we made money. That's insane in this day and world. And we also basically wanted to make sure our data was easy to change our system. So we create ourselves a set of signals. Again, Google-like. So our services begin to collect things like, oh, you just gave me a postcode, or oh, here's your email address, or perhaps here's your real address, or you just hit a page, or maybe our performance of our system is running a little slow. Little events. We just started putting these into a cloud. And it turns out when you start grouping them together, you get really interesting things going on. Remember, there's no entity here. Where is the customer? Where is the sale? It's kind of scattered across the events, stream of events. But we started seeing interesting patterns. Like if you take the postal address and the email address, you probably have an opportunity to sell an energy plan. But what happens if the email address changes? That probably means somebody new has moved into the house. New opportunity. But what if the postal code address changes? Well, that guy has moved, so maybe another opportunity. So we started backing up and saying, oh my goodness, if we collect all this little bit of data, I now discovered a use for it. I didn't pre-discover the use for it. That's the Google thinking. Just collect everything, you'll figure out useful things to do later. So we started doing that. So we have guys that are producing all these sorts of events and pushing them in there. We have consumers. We're doing a lot of stuff with R, doing statistical analysis. Yes, we do like math. But we also write some real-time things, sometimes little Perl scripts, sometimes little Ruby scripts, just collect data and stream out very interesting things. Now, we decided we park all this data into Kafka. Kafka is a project that's been given to Apache from LinkedIn. So this is the LinkedIn tracking system. We're tracking all of that stuff, relationship stuff that LinkedIn worries about. And it tends to meet the need of a cloud of events very nicely, because these events are related in various sundry ways, very much like LinkedIn is. So we use that to put that information in there. And Kafka allows streams to wake up and keep playing from where they left off. So we've been discovering some interesting things. We're discovering cross-selling opportunities. We discovered that if you're coming in on the red site, we pass traffic to the blue guys, and the blue guys pass a good bit of traffic back. So we're cross-selling products because of this. We're seeing the patterns of cross-selling. So now we know how to reinforce that with better advertising and page links. We're also seeing patterns of user journeys. We can actually now map, just by collecting this data, running through various analyses, we build all sorts of very pretty little maps that tell us, what's the center of our universe? What pages are really getting hit hard? Where do we need to reinforce ourselves? So we're collecting a lot of information about that. And one of the side effects, and this comes from another presentation I made called Programmer Anarchy, very much like the presentation you heard on the first day about GitHub. We're basically running that same sort of environment. But to some degree, we've killed acceptance tests, unit tests, refactoring, and patterns. All those things are things we do to keep a big Stonehenge running and sane. That's what we need to keep it sane in that environment. But if you kill that environment, you're writing 100-line of code services, all of those needs go away. I was quite surprised by this. Basically, our architecture has now influenced our processes in very, very fundamental ways. And again, I was surprised at that sort of result. So where do we stand in terms of technical debt in this world? Well, if you think about all the reasons we had technical debt, to some degree, the cause of technical debt, the impact of technical debt, reaching through and grabbing that number 50 and using it in 37 other places, it's hard to do that with a service. Services by their very nature, you just can't reach through and grab their instance variables. They're a service over there. They have a JSON interface. They're RESTful. And so it turns out it's very, very difficult for 100 lines of code. What if you do write a sloppy one? It's still only 100 lines of code. Rewrite it. Or maybe it's wrong. Rewrite it. It's not a big deal. It's only 100 lines of code. You have not impacted the entire rest of the universe. And so to some degree, this architecture has also reduced the risk associated with technical debt. I'm no longer worried about programmers not understanding enough about this. So it's actually helped that problem quite a bit as well. So conclusions, and I say so far because I think this is still a journey for me and the industry to go on. But some fundamental principles about microservices, they are very, very small. 100 lines of code is probably actually a big service these days. And that hits all sorts of things. You do need to make sure that decouple as much as possible. We're starting to decouple even flow things now. We're starting to do a little more pub sub and decoupling that as well. Multiple versions, not only is it okay, we probably encourage it. Because again, we can actually monitor, since it's in the cloud, this service has not been invoked for 3 months. Let's turn it off. See what happens. See who gets upset. Certainly, the services monitoring each other is very important, but it's also a key responsibility of every service to publish important events. If you did something interesting, you should publish it. Don't wait for somebody to give you a requirement for that. That says we have a need for that data. If you think it's interesting, publish it. We can find a need in the future. And finally, the whole concept of what's an application in this world, I have no idea what it is. But that's a real term that does not fit anymore. So that's kind of gone away as well. I think we are, in fact, building living software systems. My analogy here is basically that we really have a long-lived system. Some of these systems we're building are now 2 or 3 years old, but almost no service is much more than 6 months old. In fact, 6-month-old service is actually quite an ancient service. It's very much like a human body. The cells that you have here are probably not the same ones you were born with. Yet I'm still me. And we want to think about our systems that way. Don't worry about the individual parts. The entity as a whole is going to survive quite a bit. Now, in Forward, we are very aggressive about deploying. On average, from a software perspective, in fact, sometimes more often than this, I think last time I measured, we're deploying something in production every 3.5 minutes. That means average that every programmer is probably putting something in production twice a day. That's on average. So we're just pushing out stuff. Again, it's a little 100-line things. The risk is minimal. The interaction is minimal. We got the business metrics on the other end to make sure things work. We're just pumping out, see what happens. Pumping out, see what happens. We just got to understand, first of all, it is a complex system. And if you think you're going to have a giant test that ensures it's perfect, you're kidding yourself. So accept that and write your test around business metrics. And again, it had a radical impact to their hierarchies. The hardest part will be, in fact, getting programmers used to thinking this way, because this is not, we've been trained to think in Stonehenge, and this is not Stonehenge. And so we find that if we drop a programmer into the team that's doing things like this, they absorb it pretty quickly. But if you had to start out by yourself and try to think this way, you will probably get stuck. There's a theory of corporations. I got a business degree, among other things. And the idea of a corporation is we assume in corporation theory that you're running the business, that it's going to be a business forever. We're not trying to do anything stupid to kill the business. And I think the same thinking needs to be applied to our software. That we need to think about software as being something that's going to be running forever. Think about your system that way. Don't think about it as something that's going to run for the next 5 years and we're going to turn it off. I think the statistics are out from a few years ago. On average, we plan for systems to last 10 years. In practice, they live 17. So we're not even very good about guessing how long systems left, but assume it'll be there forever. So that's my story of my journey, microservice architectures. I've come a long way since the Stonehenge part, I think. I began to carve up systems in very, very tiny pieces. I'm finding it much more fun because I can write a little tiny piece and get it deployed, and I'm feeling like I deploy something every day, feeling really good about myself, versus my old IBM days where I worked on projects that delivered 5 years later. Not particularly satisfying work. All right, appreciate it. Thank you.
Are there any questions?
Thank you. Very, very good talk. So someone I know who's experimenting a lot with something that could support this architecture, right? Like very small, like sort of actor-based stuff, right? His basic thesis is that you can't support like adequate processing in a system like this because the time that you spend sort of deserializing and serializing those messages between the services is going to inhibit what you're actually ultimately going to be able to compute. Did any of these services that you guys worked on, were they computation bound? Were you worried about actual resources?
No, not really. I mean, most of our time is spent basically getting reports off Google. The analysis of that report is very straightforward. We're basically time bound relative to bringing the information across the net. And so we haven't got anything that sort of has that characteristic to it. And we're also basically, in forward, we choose businesses that have fast feedback cycles, fast business feedback cycles. We don't want to engage in a business that builds a product that takes 5 years to figure it out. We would avoid that sort of business. So to some degree, we are working in rarefied environments. But I think that I'm comfortable with that. I'm okay with that.
Thank you.
Of course. Punch cards, yes?
So once you start breaking into small services, naturally the question arises, even before the CPU bound, the question of dependencies. And how do you deal with all the dependencies that might arise between the services, unless you are in a very specific case where there are no dependencies, but
no, there are
how
dependencies.
do you deal?
That's why we have flow dependencies among them. So I can't analyze a Google report unless somebody's pulled the Google report. But it's relatively simple sort of things like that. The business domain is in many cases not that complicated in terms of its business flow. And as somebody said before, you can't make the system any simpler than the business itself. But working in some businesses that are fairly simple and straightforward. I put some ads out there, Google tells me how well they did, I pull the report, analyze the report, change my value on those ads. And those sort of cycles are pretty easy to put together. Now, the knowledge of how the system works lives within the team that's working on it. But we never write it down. But amongst them, they do have the understanding of that. And that's why we can roll people in and out of that team, because the knowledge stays in the team. But our businesses are in some ways not too complicated. Parrot cage, you just order a parrot cage, sell the parrot cage, ship the parrot cage, take it back. not the most profound businesses.
Okay, thanks.
I'm curious because you mentioned Linda Topol's, which is a very old idea from the early 80s. And during my PhD, I worked on that a couple of times. But at the end, there's a fundamental problem of scalability because trying to match very high number of tuples usually was not. Because there are many ways you can kind of, match them. How do you solve that problem? Because it's complicated.
Oh, I didn't think it was that complicated for the domain we were working in at the time, because the number of instruments were really quite clear. Now, not to say we wouldn't have had a problem if they actually said yes, but of course they said no, so I can sit here and say it worked fine, but we don't really know. I thought it was important, though, that we be able to, an accountant always wants every event that had to do with everything, so that was easy to send those over there. I think the biggest part of the render space challenge in that system was we did have multiple subscribers, and they were interested in slightly different things. But you would definitely write for instance, a physician desktop or a physician agent would basically, if he saw something critical come across, I want flashing red lights on his screen and stuff like that. But that's because it's already been marked critical. So I didn't want to over-design the data, because certainly medical field is where they got crazy with XML once upon a time and built some really elaborate stuff, and I didn't want to touch that at all. I want to make it very, very simple, straightforward conclusions sort of based. Urgent, critical, normal, and then just, that's all I care about. And it was still run rings around the legacy system, which had holes in it. So I just have to be, try to stay with that. But I don't know, because we didn't finish implementing.
Hi. I can see how the system you're talking about, the architecture, would work well for systems where the data flows in primarily one major direction. Did you ever try to apply this to a system that requires something like user experience feedback, where there's things like error conditions that have to be bubbled up immediately back to the user?
To some degree, the web sales with uswitch, we were doing switching, that's basically a web-based front-end, highly interactive stuff. It has a bit of those characteristics, but we're not talking about, I would say, anything more than e-commerce sort of sales kind of concept. So I would say untested in that field. One of the things I'm doing, I started work last Monday for an online newspaper. So I'm now going to take a lot of these ideas and apply them to a new domain. Online publishing stuff, to sort of see how much of this stuff works. I'm comfortable that it definitely all worked for us in Forward, but Forward is a relatively strange place in some ways. So therefore, we just really take advantage of that in some ways. So I wouldn't necessarily imply it works for your environment.
So the 100-line services is really catchy, and I actually do enjoy, and I want to move to this thing for just us in general. But what about the orchestration and discovery and routing? That's certainly not a 100-line service, is it?
Well, first of all, I think you're doing orchestration, you're building a God class. So I don't believe in orchestration. I worked with Jim Weber, that was the era of orchestration, and basically you're building this God class that we used to have in our big systems that said everybody flows to the God class, he decides who gets it next. I think that's a dead idea. I mean, it's not redundant, it doesn't scale, it has all those other issues. I'd much rather sort of distribute the intelligence. That's why I want to publish into a bus that says I have something interesting, and you subscribe because you're interested. And I want to decouple those two pieces. I don't want orchestration. I'd rather have decoupled interest in PubSub stuff. So that was a deliberate choice on that side. I do believe if you get stuck in trying to build this God classes or God services or what you call it orchestration or whatever, you're probably going to go down a rat hole that's going to kill you. Now, I don't think I answered the whole question, though, did I? Oh, yeah, I've already made that mistake. Thank you very much. I'm not going to try that one again. Yes?
So, especially when you start talking about data flow systems, how do you deal with different timescales and events on different timescale systems? Because a lot of times events need to be synchronized across services. So what do you do if you have, for instance, services that require some, I guess, similar idea of temporality?
We don't tend to have that in our industries that we work with. I mean, the closest thing we have to sort of synchronization is I can't obviously analyze a Google report till I have it. But that's sort of the highest level of temporal dependency we have. We have I don't think I can think of any case where you have two things that have to be coordinated and therefore before the next thing happens. But if I did, I would probably drop them in some non-relational store, and that the servers will keep waking up and not finding it. If you didn't find it in time, he raises a little hand saying, I can't run. But in general, we prefer the system to fail than try to do defect prevention. It goes back to our whole, if you think about it, tests themselves are not lean in any way whatsoever. Because tests are there just in case something goes wrong. Anytime I use the word just in case or it may be necessary, I've now moved outside the lean, agile world. I'm doing something almost by rut. I really want to be just in time in these sorts of things. I'd rather have a system fail fast than do defect prevention. And so that's why my unit tests have gone away, because I'm deploying twice a day. I have my business metrics to tell me when I screwed it up. I don't need to write those tests. So to some degree, the temporal things I would try to set up as a failure in my system first before I try to do the coordination. But again, we don't tend to have that in our domains, or at least not that I can think of. And I got to shut up, apparently. I saw the hand waving.
Okay, I'm afraid we have no more time for questions, but thank you, Fred.
Thank you.
Applause.